All right, we're going to go over the Unit 5 test review. So, number one, write the equation 4 to the third equals 64 in logarithmic form. So we're just writing in log form. This one should be nice and easy. Log base 4. And all you do is switch the input and the output like we did originally. So log base 4 of 64 equals 3, and you are done. Number 2, evaluate. When I ask you to evaluate, we talked about this a lot in class. Essentially, that just means I want to know what that is. So we're going to evaluate it in our calculator. Remember, you do log of 1 divided by 729 divided by log of 3. Remember, there is a log base button in the calculator, but we don't use it because you need to know that these two are the same for your tests. And there you go. Your answer is -6. Number 3, solve. The only way to get rid of a logarithm is to go into exponential form. Exponential form does not have the word log in it. So it's 6. And you just, again, switch the input and output to the -3rd equals x. And then I need to evaluate the 6 to the -3rd. 6 to the -3rd. And yes, I want you to put it as a fraction. 1/216 is your answer. Number 4. Number 4 we went over a lot in class during your test review. And because this is the most missed question on that quiz we took. Addition. We're not distributing logs, we're not doing any of that. Log base 5. Addition means multiplication. m-1 times m-1 equals 2. What is the only way to get rid of a log? Just like we did in the last problem, exponential form. So it's 5 to the second equals m-1 times m-1. Now, yes, I'm going to go ahead and box those out. So I have 25 equals m squared. Remember, these should be easy to box their foil in your head. Add 2, so -2m, multiply plus 1. Subtract the 25 over. M squared minus 2m minus 24, and we can then do the quadratic formula if we want, or if it's factorable, we should just factor it. So let's factor it. Factor to 24, that get me to 2, 6 and 4. I want -2, so -6 is +4. So my current answers are m equals 6 and -4. We still have to check for extraneous solutions. Extraneous solutions exist because we cannot take the log of a negative. If I plug in 6 here and here, I get 5. That's good. If I plug in -4, I get -5. That is not good. All right, number 5. Similarly, I need to use my properties first. Subtraction means to divide. So 4u plus 10 divided by 4. No properties over here. We're good. The difference is this one only has 1 log. This one has 2 logs. And if you remember in class, I went through a proof that showed you how to put each of these in exponential form separately and then set things equal to it. What it ended up doing is made you think of it as these logs get to cancel out. And I cautioned you with that, but yes, that's essentially what is happening. So I get 4u plus 10 has to equal over 4 equals 2u. You could multiply before, you could just find a common denominator. Common denominator is going to be 4. This one needs the 4. Cancel. So I get 4u plus 10 equals 8u. Subtract the 4u. 5 by 4. You get 5/2. We still need to check for extraneous solutions. But 5/2 times 4 plus 10 is still going to be positive, and 2 times 5/2 is also still going to be positive, so it does work. What is the approximate solution? This is day 6. How do I know it's day 6? Because it has 2 exponents. Day 1 is the type that has 1 exponent. This has 2 exponents. So here we go. This is the type where we take the log of both sides. What that allows us to do is move the x plus 1 down. moves the x down. Next thing we're going to do is distribute. So I have x log 2 plus 1 log 2, which is just log 2, equals x log 5. And then remember, this is where I said stay, go, go. We're moving things on the correct side. So x log 2 stayed, minus x log 5, negative log 2 went over there. And then the last two steps are to factor out the x. Log 2 minus log 5. And then divide properly. So I'm going to make sure that I have the correct one on top and bottom. So it's going to be x equals negative log 2 over log 2 minus log 5. Remember, I said it's probably a good idea to type that, to write that on your answer sheet line in case you type in the calculator poorly. Remember, full top, full bottom, and then log will open one, you close it. That's what we're going to type in right now. So I do parentheses negative log 2 close close divided by open log of 2 close minus log of 5 close close enter, and you get your answer. Remember, 3 or 4 decimals is good with me. Number 7, what is the approximate solution? Some of you might want to try and do day 6 for this one. And in theory, not in theory, you can. It's just a longer process. This is easier because it only has one exponent. Log base 2, switch these two, of 16 equals 2x minus 5. And then we're going to evaluate this part in our calculator. So log of 16 divided by log of 2. We're going to get our answer, and I still need to solve for x. So I add 5, it's my answer, and then divide by 2. And there you go, 4.5 or 9/2. Number 8, just your properties. Be careful. The two biggest mistakes I see with these properties are you write more than one log. You should only have one log in your answer. Your answer should just have one log base 3 in your answer. The other thing I often see is plus and minus signs. No, they change. You know these properties pretty well. First property that we need to use, coefficients, they become exponents. Then we do the rest of the properties together. Log base 3, any of the addition or positive ones go on top. This was positive, so the x cubed goes on top. This was subtraction, y squared goes on bottom. This was subtraction, the z goes on bottom. What I constantly see people do is put a subtraction sign in between these two. No, subtraction means the division. If I have two things on the bottom together, they are being multiplied together. Correct answer. You are done. Similarly with number 9. 2, exponent, 2, exponent, 3, exponent. Leave the subtraction where it's at. You can do one of two things. You can simplify now or simplify at the end. A lot of you like to simplify now, so that's 16 to the third is 8. All right, and then we're doing the same thing. 1 log base 2. Let's draw our fraction bar. 16 goes on the top because that log was positive. Y squared goes on top because that log was plus. 8 was minus, so it goes on the bottom. And then yes, if possible, simplify. So I get log base 2 of 2y squared. Don't make the same common mistakes I see over and over and over again. 10, find the inverse. Inverse is where we switch the x and y, resolve for y. Just make sure you're doing it in the right order. It's order of operations backwards. So pay attention, watch carefully. So I'm going to move these in the correct order. First one, order of operations backwards. I'm moving the 3 by subtracting it. I'm moving the 2 by dividing it. I'm moving the squared, the exponent, by square rooting, remembering my plus or minus. And finally, I'm moving the minus 2 by adding it. You are done. Let's go over your rules real quick. Your rules for linear, domain, and range are both always negative infinity to infinity. Your rule for quadratic, your domain, negative infinity to infinity. We can square any number we want. Your range is going to either be, remember, k to infinity or negative infinity to k. Exponential. Your domain is always negative infinity to infinity. Your range is going to be the same thing as quadratic. The difference is it's not included because there's going to be an asymptote. Scroll back up in a minute. Or negative infinity to k. The only difference between quadratic and exponential is the bracket. Logarithm is just the opposite, right? I'm going to do logarithm. Pay attention. I'll fix it again. Logarithm, the only difference is domain, range, and instead of k, you would be using h. Oops, sorry. You have those in your notes. All right, let me put the exponential back up there, though. This is important, because guess what this one is? Exponential. So what's my domain? Negative infinity to infinity. What's my range? -2 to infinity. How do I know it's not negative infinity to -2? My a out here is positive, because it's 1. All right, is it a function? Yes. Of course it is. All right, inverse. I'm going to erase our rules so I can have room to do our inverse. Sorry, rules. All right, let's find our inverse. X equals 5, y minus 3, minus 2. Add 2. For some reason, so many of you can't do this problem when it looks like this, but what if I write it like this? It's just an exponent. I'm trying to solve for y, and y is in the exponent, so I need to use logarithms. Log base 5 of x plus 2 equals y minus 3. The last thing I need to do is add the 3. That will be my y prime. What's my domain going to be? -2 to infinity. What's my range going to be? Negative infinity to infinity. How do I know that? It's just the inverse of those two. Yes, they are a function. My suggestion to you on graphing these. 5 to the x minus 3 minus 2. My suggestion for graphing these. First of all, there's a graph down here somewhere. Well, I didn't put a graph up there. There'll be a graph on your test. So what I would suggest doing is graphing this one. So drawing your horizontal asymptote, picking a couple nice points, and then the easiest thing to do, instead of typing the logarithm, is do the inverse. So I'm going to draw my vertical asymptote at -2. And then I'm going to take these two same nice points. The difference is I'm going to flip the x and y. So if they're, let's actually do some. So let me go to my calculator. Let's pick two nice points. Let's do 3, -1, and 4, 3. No, I almost did. 3, -1, and 4, 3. It's pretty close. So instead of 3, -1, I'm going to have -1, 3. And instead of 4, 3, I'm going to have 3, 4. And then I'm going to draw my exponential. All right. 13, investor plans to invest compounding continuously. You got to memorize the formulas. It's on the sheet for you right now. To memorize the test, take PERC. He's investing $25,000. That's my starting amounts at a rate of 0.0425. How long will it take for him to double his money? So I want 50,000. I don't have my time. Step 1, divide by that 25,000. Gives me 2. I want to use natural logs. natural log of this side just becomes natural log of 2. We had a lot of talks about what the natural log does to that side. The first thing it does is it brings down the 0.0425t, and then we remember that the e kind of goes away because the natural log, this would say natural log of e, but the natural log of e is 1, and 1 times anything is itself. So essentially it just becomes our exponent because of our use of logs. Last thing I can do is divide by the 0.0425. Type in my calculator. Natural log of 2 divided by 0.0425. Enter. There you go. Approximately 16.31. And remember I said if I don't say, we'll assume we're in years. 14. The growth of strain of bacteria is measured in days. Okay, so I'm still using a per. How long will it take 10 bacteria to grow to 20,000? E, K is my constant. I know a lot of you asked why it starts with K, and we talked about it. That's just my rate, and it already is as a decimal, so I'm good. And we're going to solve this the exact same way we solved last problem. Still a per. We're going to divide by 10. We're going to take the natural log of both sides, send the natural log of 2,000. Again, what's the natural log of 2 to that side? First and foremost, it drops the exponent down. And second, the natural log of e is 1. So then I go to my calculator. Natural log of 2,000 divided by 0.725. There you go. It will take 10.48 years, or days. This one's in days. 15. A lot of you asked me 15 in the review. A radioactive substance case according to the equation. A lot of times in the NCFE, they will give you an equation. What equation do they actually give you? It's just a perk. This is a perk. That would obviously represent my rate. Okay, so what's the half-life? Remember, our half-life is similar to a perk, except for it's just 1/2 ERT. That's my rate. How do I solve this problem? Natural log. Natural log of 1/2. Again, what does the natural log do to this side? Drops the exponent. What does it do to the e? Cancels it out because the natural log of e is 1. Divide by my negative 0.0836. So I get the natural log of 1/2 divided by negative 0.0836. There we go. 8.29 years. 16, using blah, blah, blah. Oh, depreciation. AP1 minus the rate to time. All right. The machine will depreciate at a rate of 11%. 0.11. The machine was purchased for, that's when starting. After how many years will it have depreciated to just $50,000? All right, so we're going to divide by 450,000. And those cancel, that cancels, you get 1/9. And we go ahead and subtract these, you get 0.89. And then we still have to use logarithms, variables still in the exponent, but in this case, instead of natural log, we're going to use regular log. Again, some of you are struggling writing this in log form, and I implore you, well, let's just write it like this. Let's put the exponent on the left-hand side, then you can. Log base 0.89 of 1/9 equals t. Those are nice. Evaluate in our calculator. Log of 1/9 divided by log of 0.89. There you go. 18.85. It doesn't say. We're going in years. It does say. 17. Marriage purchased commercial property 6 years ago for a blah 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 blah. Growth rate. What is the approximate rate of appreciation? All right. It says 6 years ago for 115. but now it's worth 192,000. I need to know the rates. We had it for 6 years. Divide by 115 like always. I get 192 over 115. 1 plus my rate to the 6. This one's different. I don't need logarithms. The variable's not in the exponent. So the question is, how do I get rid of a 6 as an exponent? I take the 6th root, which is the same as, we've talked about it over and over and over again, same as doing what? Good. Raising it to the 1/6. 192 divided by 115 to the 1/6. And then I have to subtract 1. But why am I subtracting 1? Because it's 1 plus r. And then I'm going to make it a percentage. So 8.92%. Write an exponential model of that given table. Remember, don't use any crazy decimals. Stat. Edit. I'm just going to use the first 3. 0, 1, 2, 5, 1.5, 0.45. Quit. Stat. Calculate. It's 0 for exponential regression. 0 for exponential regression. And down to calculate. Enter. You'll notice you don't see my r squareds because I reset my r squared and my r because I reset my calculator. My diagnostics are turned off. I could turn them on, but do I need to? No. Why not? Because it tells me what model I want. So I'm done. Y equals 5 times 0.3 to the x. 19. Write an exponential model given the graph. Great. Stat. Edit. -2, -1, 0. Use all of them. 0.125. 0.5. 2. I could use 1/8 if I want to too. I don't need to though. It says exponential. Stop. Calculate number 0. And there we go. Again, I don't have my diagnostics on, but I don't need them to be on. I don't need them to be on because it tells me what type of model. You need your diagnostics if it doesn't. It asks for the best model. 20. Oh, time for some review problems. Unit 1, find f of 2. Remember the easiest way I showed you how to do this was to use our store function. So we're going to do -2, store it into x, and we're going to type in our function, x to the 3rd minus 9x squared plus x plus 12. So the key is always what we write here, and people are still messing it up. So I write f of -2 equals -34. What does that mean? It means that x plus 2 is not a, this one people keep screwing up, factor of f of x. Not, a lot of people keep trying to write the word function. No, x plus 2 is not a factor of f of x. 21, we had a lot of good conversations about how to solve this from Unit 2. These are just cubics. First, the easiest way to solve a cubic is to graph it. Let's try and graph this. X to the 3rd plus 8x squared plus 19x plus 14. To find any and all rational zeros that I can. So I'm going to go far left. Second trace 0. Let's do the one on the far left. That's not rational. That's no good. Then some of you thought, well, and I heard good conversations about talking about, do I think that's a double root right there? Well, I can't tell. I mean, it could be. It could be. So let's zoom box. But I don't need to keep that 0 in there. I just need these zeros. So when I zoom box here, this could be 1 0, it could be a double 0, it could be 2 zeros. You clearly see that it is 2. So let's find one. Second trace 0. Left of it. Right of it. Irrational. Second trace 0. left of it, right of it. There we go. -2. That's an answer. Now I'm going to do synthetic division. 1, 8, 19, 14. Bring down the 1. Multiply. Add. Multiply. Add. Multiply. Add. You should get a 0. Now I'm down to my quadratic. It's time to do the quadratic formula. B squared minus 4AC. Now remember, you get to type that exactly how you see it in your calculator. Type it all in at once. You should get 8. 36 minus 28. Opposite of B. 2 times A. Square root of 8 breaks up into 2. 4 and 2. 4 comes out as a 2. So I have -6 plus or minus 2 root 2 over 2, which reduces to -3 plus or minus root 2, because all 3 of the outside numbers are divisible by 2. Now I keep getting some of you putting that as your answer on your answer sheet. That's good. You did the problem right. You didn't write all the answers. You have to include the -2 you got from the graph originally. You did 3, now we're going backwards. So I need to write all the zeros. Remember, those come in pairs. Time to write the factors. -1/2 would be 2x plus 1. 2 goes with the x, plus 1. Next one would be x minus 2 plus 3i. Next one would be x minus 2 still, minus 3i. Remember, we're just changing signs. Now we're boxing. I'm going to box these two together first. These are called conjugates. Those cancel, so I get x squared, -2x, -2x, positive 4. Remember I told you that one? Easiest way to do it is just go to your calculator. Because a lot of you are going to forget what I squared is. 3i times -3i, you'll get positive 9. You combine like terms. That gives me x squared minus 4x plus 13. Those of you wondering where I got 13 from, where did I get the 13 from? Good. Combine like terms. I'm going to box that with 2x plus 1. That gives me 2x cubed minus 8x squared, 26x, x squared minus 4x plus 13. Combine like terms, finished off. Gives me 2x cubed minus 7x squared plus 22x plus 13 equals 0. I could ask you for an equation. Make sure you write that equals 0. Parent function. Parent function. Transformations. What do they do? Negative flips over the x-axis. 3/2 vertically stretches because it's above 1. Plus 5 on the inside. Left 5. Minus 1 on the outside. Down 1. 24. Vertical and horizontal. Vertical are easy. Factor everything. So my points of discontinuity are x equals -3 and x equals -5. They both stay vertical asymptotes. Remember, if there were an x plus 5 up here, there's not, but if there were and those canceled out, would it be a vertical asymptote? No, then it would be a hole. This question didn't ask for a hole, so you cannot leave it in your as a vertical asymptote. All right, if they cancel out, I don't ask for holes, do not list it as a vertical asymptote. I didn't do that. This isn't like that, so those are both vertical asymptotes. Horizontal asymptote, the same. Bobo, clown. Bottom. Eats. He's hungry. DC. Bigger on bottom, it's 0. Bigger on top, it's none. Exponents are the same. Divide coefficients. Again, this is always talking about your degree, so which is your highest exponent. So this is definitely bigger on bottom, so the horizontal asymptote is y equals 0. Unit 4, common denominator time. X plus 4, x minus 4. So my common denominator is x plus 4, x minus 4. Restrictions are x cannot equal -4 and 4. First fraction doesn't need anything. Second fraction needs the x plus 4. And the third fraction, which is now written as a fraction, needs the both. X plus 4, x minus 4. Once we have common denominators, what do we do with them when solving? Good, we get to cancel them out. So then I'm solving this equation. 6 minus 1, x plus 4. Equals 1, x plus 4, x minus 4. Alright, 6 distribute, minus x minus 4. Box those two together, you get x squared, add them, 0, multiply them, -16, times 1, distribute the 1, great, we get x squared minus 16. This is a quadratic, so let's move everything to one side. I'm going to go ahead and find like terms first. That gives me negative x plus 2. So I'm going to add the x. I'm going to subtract the 2. And yes, I will try to factor if it's factorable. It is not factorable. So we're going to do the quadratic formula. B squared minus 4ac. Again, type this all in your calculator exactly how you see it. I'll do it. 1 squared minus 4ac 73. On the front, opposite of b. On the bottom, 2 times a. 73 divisible by 4. No, 9, no, 25, no, 49, no, it's not. So there are your answers. You still need to check for extraneous solutions with these. Remember, extraneous solutions occur when your answers match your restrictions. Obviously, those don't match those. You're done. And I'm done. Short video. 33 minutes.